Good afternoon, everyone. I am John Suho. People call me John Suho. I'm a security engineer at InterSystems, and most of my time is spent doing vulnerability management, but they let me moonlight by giving presentations on fun security topics like this one. This is our second session on OAuth 2, which discusses using OAuth 2 with InterSystems IRIS. My colleague Pravin Barton will talk to us at the end of the session about using OAuth 2 and OpenID Connect for single sign-on using IRIS, so stay tuned for that. But the rest of our agenda today, first we'll have a world review of OAuth 2 concepts that we covered in the last session. Then we'll have an introduction to OAuth 2 roles in InterSystems IRIS instances and prerequisites, things you have to do before you configure them. We'll take a look at a demo of setting up an IRIS instance as an authorization server. We'll take a look at setting up InterSystems IRIS as an OAuth client and or resource server. We'll look at a quick example of using IRIS as an authorization server and a different instance of IRIS as a resource server using a third-party client, in this case Postman. We'll look at another example in which the authorization server is a third party, in this case Google. The resource server is going to be a Google application, in this case Photos, and IRIS and a web application therein are going to be the client. Then I'll turn things over to Pravin to talk about SSO with IRIS and some nifty practical details. So let's get started. We did this in 40 minutes last time, so let's see if we can do it in just a couple. The gist of it. OAuth 2, Open Authorization, is a framework to grant specific permissions on particular resources so that others can access them in the specific ways intended. There are many terms, some of which we'll go over. A resource. This is the particular data or operations that an application wants to get a hold of. Scopes. This is the specific permission being requested on that resource. A scope is just in the form of a string that the logic on the other members is going to decipher. The resource owner is the person or identity that owns the resource. Much of the time this is a human user. The client is the application requesting access to the resource. The authorization server is the entity that gets permission from the owner to grant access to the client and will grant tokens. The resource server hosts the resource and will grant access to it if presented with the proper token with the proper scopes. An access token, as the name implies, is a token that allows access to the protected resource. Tokens can come in a couple of different formats: JWTs, JSON Web Tokens. These can be read directly. They can be signed, and I want you to sign them to be verified for authenticity and validity. Opaque tokens are just proprietary string formats. These have to be submitted back to the auth server in order to find out what they say. Endpoints, URIs that exist on the auth server for different purposes. The authorization endpoint, where the resource owner, the user, can approve access to grant privilege to the client. The token endpoint, where the client can request a token. The introspection endpoint, where the resource server can check a token, or sometimes the client as well. The client ID. This will be an ID akin to a username that is issued to a client when it registers with the auth server, a client secret. This is a value akin to a password that may or may not be given to a client when it registers, depending on its ability to keep it secret or safe. Confidential clients run in controlled environments. They can be given a client secret because it won't be stolen, meaning they can use their client ID and client secret to authenticate, like a username and password. Public clients run in uncontrolled environments. They don't get client secrets because they can't keep them safe. They have to authenticate in other ways. Grant types, these are the different options for the flow or procedure of how resource owners and clients get authenticated to auth servers and how the client actually gets a token. And there are different ones that are suitable for confidential versus public clients. The audience, this is a field and an access token that you can set in order to specify which resource server it's meant to be used for. Some resource servers are really stringent about making you set this properly. The OpenID Connect, this is an extension to OAuth 2 that allows you to use the framework for authentication instead of just authorization. An ID token is a token used in OpenID Connect with information about a user that is issued in addition to any OAuth 2 access tokens. So those are our terms and a bunch of pictures that make a lot more sense if you saw the last session. Let's talk about what you need to do to use InterSystems IRIS with OAuth. Well, the first thing you need to do is understand your own architecture and know what role that IRIS or other applications are going to play. Is IRIS going to be the authorization server? Is IRIS going to be the client app? Is IRIS going to be the resource server? A single InterSystems IRIS instance can be all three of these at once, or you can spread them out across lots of other instances, or the instance will only play one of these roles and you'll have other applications that play the other roles. You'll need to know that before going in. So how does an instance play each of these roles? Well, as an authorization server, there's an auth server configuration with settings, the most important of which are customization classes. This is where you can specify classes that perform each of the different functions of the auth server. Presenting the login page, validating the credentials, actually creating the token, whether that's a JWT or an opaque token. We, as InterSystems, provide some default classes. For some of those functions, the default classes are pretty good for general use. For other ones, you definitely want to customize them to whatever you need. If you're using InterSystems IRIS as an OAuth 2 client, there is a client configuration, and the first thing you'll do is you'll point that instance's client to an authorization server by making a server description. So you'll put in the information of that auth server, and then you can create individual clients hosted on that instance and get them registered to that auth server. InterSystems provides object script classes and methods to get tokens from the auth server and save them to the instance. Check to see if the instance already has the desired tokens that you want, and then attach those tokens to an HTTP request that's going to be sent to a resource server. IRIS is an OAuth 2 resource server. The configuration of a resource server is exactly the same as a configuration for a client. We use the same configs for both resource servers and clients. You point them to an auth server, and you can make as many resource server configs as you want out of those client configurations, even though they're technically not clients. And we provide object script classes and methods to extract tokens sent by the clients and HTTP requests, and check to see if the tokens are valid and have the desired scopes. Now the prerequisites. These are all very big topics in and of themselves that we will not be discussing. You will need to configure your web server or web servers with HTTPS, that is SSL TLS, work with your web admin and your security admins to get certificates and choose settings that meet your org's requirements. There is no InterSystems IRIS involved in this part. The next part is installing and configuring the web gateway to point to your instances. Instances will be involved in this part. And then, on your instances themselves, you'll need to set up SSL TLS configurations, those will be client configurations, that will later be used to reach out and connect to the web servers that serve the other roles. Again, they're all big topics that we won't talk about. All right, what we will talk about is how you manually configure these inside of the management portal. System administration, security, OAuth 2, and you'll see these three sections. Administration, you really won't need to worry about. That's a very, very niche section that you really don't need to look at. Server means authentication server. Client is where you configure clients and resource servers. Okay, so now I'm going to show you a video of configuring an authorization server. So let me make sure that this is set up the way that I want it to be. Okay. Is it playing? I don't know if it's playing. Okay, now it's playing. All right, so I'm in the management portal. I go to the server section of my OAuth 2 part, and so I'm going to give it a description. That's just a name. This next part is very important. This is filling out the issuer endpoint. This is telling the auth server how to talk to itself. And later on, we'll copy this URL that it generates to copy into the clients. But you'll need to give it, the host name that serves this instance. If you're using a non-standard web server port, you'll use that. If you're using a CSP or a web gateway that puts in a prefix to talk to this instance, you'll put that in, and then you'll copy that link there. The most important setting here is to turn on PKCE enforcement for public clients, because again, public clients need to authenticate themselves, and you don't want to let in a public client that's not going to give you PKCE, because it doesn't really authenticate itself. You could do it for confidential clients too, but they have other ways to authenticate themselves, so we're going to skip that part. We're going to skip a lot of this other stuff, the front channel logout, the refresh token, but we do need to talk about the grant types. We talked about grant types. You and your application and your admins need to decide what grant types are going to be supported by this resource server and all of the clients, and depending on what the capabilities of the other applications that are going to connect to this are going to be. The OpenID provider documentation, purely informational, we'll skip that. The SSL TLS configuration, you're going to need that, so you'll have set that up earlier, and you'll put the name of it in here. And then there's the Scopes tab. You can create certain named scopes. I've created the fantastically named Scope 1. A lot of scopes on external auth servers look like URIs. So here's an example of creating one that uses a URI format. There's also this checkbox underneath to allow unsupported scope. That just lets clients ask for something that's not on this list, and what actually happens will be decided by your customization classes. There's also a default scope in case they don't specify any scope. Intervals tab, just how long do tokens last, how long do sessions last, things like that. JWT settings, I like on the server to set a default signing algorithm. It's much more important to set that on the client, but if the client doesn't specify it, the server setting will do that. Again, if you don't sign your tokens, then somebody could just make one, and there's no way to tell they're not from you. Here are the customization options. These are the different classes. This class at the top, the Authenticate class, this is the login page that the user is going to see, and also the page where they approve access. Ours, we offer a default gray one. You can customize that to look more like your branding. The second one is very important. The Validate class, this is what's actually going to check the username and password, what logic is going to be used there, and to kind of decide what is going to be asked for in the token. So if you're going to change one class, this is the one you want. The default class checks the username and password against IRIS password usernames and passwords. That's probably not what you want. It also allows the user to approve any scope that is asked for, which is also probably not what you want. So please customize this one to your own liking. Excuse me. The one below that, the session maintenance class, that is just how the session is stored, how in case the user is logged in recently, they don't have to log in again to grant a second level of access. That is just by default stored in a cookie. That's probably fine for your purposes, but up to you. The generate token class. We ship 2 of them. The default one is .generate, which makes an opaque token. You probably want to switch that to .jwt, since you're probably using JWTs, but up to you. The revoke class, I would not worry about so much. And then the namespace, in case you're putting these classes in a different namespace than %sys, and then what roles they need to run as to execute properly. So we'll save that. Now we have an auth server, and we can create client descriptions directly on the auth server, but you probably won't if you're using an instance as the client. I'm going to show you how to do that and dynamically register them. But you can make them if you're using something else as the client. You can create it here and then copy that. But we also just offer dynamic registration. And if your client does that too, that's fine. Some external auth servers don't offer dynamic registration, as we'll see. So we're not going to make it here. We're going to make it in the client section. Whoops. So now we're going to go over to the client section, and we're going to create a server description, and then we're going to make a confidential client, a public client, and a resource server. So, is it playing? Oh, I have to click up here. I can't hit the play button. Grand. Okay, so we go to security OAuth 2 client, and eventually it'll go through. It seems to be playing. So we're going to make a server description. So we need to put in the issuer endpoint. Now we're going to jump over to where we created the server, and we're going to copy that URL that it spit out. And that's going to tell this client how to talk to the auth server. And then we're going to choose an SSL config, and then we're going to hit discover and save, and the client instance is going to reach out to the auth server and get all of its endpoints, all of its supported algorithms, and that information. So now this instance knows about the auth server. So now, you see the server description there, we can go in and we can create client configurations, and that's what we're going to do. First, we're going to make a confidential client. There's two names here. There's the application name and the client name. The application name is, what is this client called inside my instance? Like, how do I refer to it in my code? The client name is, how are we going to register this when we dynamic call out to the server and dynamically register this client? Obviously, there's enabled. We're going to choose client type of confidential. We're going to give it an SSL TLS configuration. The client redirect URL, this is how to talk to this instance as client. So we're going to grab the host name that serves this instance as client. We're using a gateway that needs a prefix to talk to this instance, so we're going to put that in. And if you were going to talk to an auth server that didn't dynamically register, you'd need to copy this and put that up there to be on the approved list. We're skipping front channel logout. Put in the grant types. And for authentication type, for a confidential client, we can use basic, because we're going to have a client ID and a client secret, so we can just send an auth header with those as the credentials. Client information, don't need to fill anything out. JWT settings, the ID token is always going to have a default signing algorithm, because that's part of OpenID spec. Access token algorithm does not have one. Highly recommend specifying that, because you want your access token signed so that no one can just make one and pretend to be you. Client credentials, these are going to be blank to start with, but we're going to hit dynamic registration and save. So we're going to, as client, reach out to the auth server, and then we're going to get a client ID and a client secret, because we're a confidential client. So you'll see both of those there. All right, I'm going to pause us here, actually, or try to pause us. Oh, dear. Uh-oh. That did not work as well as I was hoping. Uh-oh. I shouldn't have paused us. Whoops. That's lovely. So we're going to watch this whole video again. Ah, there we go. Okay. Yeah, so I'm going to take us to wherever we were. So I'm going to take us to right after this point. So we got a client secret and a client ID after we dynamically registered. And pausing there, after we dynamically register, we don't have dynamically register and save button anymore. We have a save button and a get updated metadata and save button. Those are different. If you make changes to this client on the client side, you hit save, that's going to take the information on the client, send it to the server, and make sure it saves there. If you hit get updated metadata and save, that's going to check the server to see if anyone made changes, pull those in, and save them on the client. Know the difference between those two buttons. Grand. Okay, so now we're going to make a public client exactly the same way. Put an application name so that we know what it's going to be called in our code on this instance, a client name so we know what's going to be called on the auth server. Give it an SSL configuration. The host name, the client redirect URL, how to talk to this instance. This is going to be sent to the auth server and be on the approved list of URLs that you can be sent back to that can receive codes and tokens. We're going to choose our grant types. For public clients, we're going to switch to form encoded body. Why are we doing this? If we send a basic auth header, we're going to send a client ID as our username, but we're not going to have a client secret. So it's like sending a username without a password. It's going to get very confusing. So we're going to put the information in the body instead so that things don't get confused. Client information, again, don't need to worry about. JWT settings, again, please set an access token signing algorithm. And again, we're going to dynamically register and save and get back a client ID, but not a client secret because we're a public client and we can't be trusted with one. And finally, we're going to make a resource server, which is just a variant on a client config, even though it's not really a client. So we're going to choose the resource server option, and then a bunch of our options are going to disappear. There's no grant type because a resource server isn't going to ask for tokens. But we do need to set an SSL config, and we do need authentication type because we might need to talk to the auth server. Much less information there. No access token settings because we're not going to ask for access tokens. But we are going to get some client credentials when we register. And so that's how you make a resource server config, which you may need to do for your web applications. Okay. Thanks kindly for that. You can also make these programmatically, so you don't have to make them by hand if you don't want. So in our first example, our authorization server is going to be an InterSystems IRIS instance. Our client is going to be Postman, which is an HTTP tool if you're not familiar with it. The resource server is going to be a different IRIS instance hosting a web application. The scope is going to be that very cleverly named scope 1. The resource owner is going to be me and my user on the auth server. And the resource is going to be whatever the resource server code gives you if you can prove you have a token with scope 1. So let's take a look at that video, which I promise I won't pause. Okay, so we are on an authorization server. I've made a couple of different clients. I made a confidential client, a couple public clients, and a resource server. So we're going to do this, get a token for both of the confidential client and the public client. We have the redirect URIs. So this is the allowed list of things that are allowed to get codes to get tokens. An instance is on there, but you can also see I put one in that sends the code back to Postman. And there's some other tools in there. So you'll need to put this in the resource server if you want to use multiple applications with the client. We choose our grant types. We're just going to go with authorization code still. The supported response types, we're only using authorization code, so we're only going to get an authorization code, and we're not asking for any ID tokens. We did use basic authentication because, again, we have both a client ID and a client secret, so we can sign in with basic authentication with those. And in a second, we'll jump over to Postman, and I'll show you where to configure those in there. So we're in this authorization tab. We've chosen type OAuth 2. And so we're going to give this token a name to save it under. The grant type is authorization code, which we can use because we're a confidential client. The callback URI is how to get the authorization code back to Postman. Postman should give you this, or whatever application should tell you what to use here. The auth URL and the token URL, these are endpoints on our IRIS auth server. We put in the client ID and the client secret. And then I believe we ask for the beautifully named scope 1, and the state is just some random temporary security value, and we're going to leave basic auth header because we can do that with a confidential client, and then we're going to clear cookies so we can go through the whole process and hit the button, and look at our lovely generic login page. And logging in as our wonderful user. And it says, do you want to give this client this scope? We say yes. And then we get a token that you can see inside of Postman. So now I'm going to do exactly the same thing with the public client. So let's look at the public client in our auth server configuration. So again, it's of type public. The redirect URIs, we've put in several, including one for Postman. We are still just using authorization code grant type. We're still just getting a code back because we don't want any ID tokens. We're setting form encoded body because the public client is only going to have a client ID, not a client secret, and so using a basic auth header would be confusing. And let's show you a client ID with no client secret. Okay, and we've put that information into Postman. Again, so we've given the token a name to be saved under. Grant type, we're using authorization code with PKCE, which is what you need to do if you're a public client who actually wants to authenticate themselves. Callback URL to send us back to Postman. The auth URL and token URL for our IRIS auth server. We put in the client ID. We have no client secret. Still our beautiful scope 1, some random value for the state. Client authentication we've changed to be in the body, like we said, so that it doesn't confuse things. We're going to clear cookies so we can go through the whole login process again. And we hit the button. We log in. We grant access. We get a token back. So we're going to copy this token, and soon we'll put it in a request to the resource server. But right now we're going to look at the resource. Resource server code. So what's it going to do? So first, it's going to grab the access token out of the HTTP request. This is a standard OAuth class for resource servers. We're going to validate the JWT. So we'll check the signature and make sure it's not expired. Then our code is going to check the scope. Hey, is this the scope that we want? So it's going to do that. Then for good measure, we're going to do all of that the other way. So we're going to send it off to the introspection endpoint. We're going to get introspection. We're going to send it off to the auth server so that it can check it. Once it gets back and it's successful, then we're going to check the scope again. And after that, this is technically the resource. So what we're sending back is some information about the token itself, and then we're serving up this lovely image. So that's what's going to count as our resource here. So you go in, we're going to call out. So we are using basic auth. We could put the token in the auth header, but our instance isn't set up to do authentication with the token, just the authorization. So we're going to use a username and password here. And put the token in the body. So we're going to put the token there, and we're going to hit send, and look, we get back some information about the token and this lovely picture of a lawnmower. So that is beautiful. Oh, one more extra thing for people who are very interested in this. If you need to specify an audience, if you're, you can do that here or in whatever your client application is. Sometimes resource servers are finicky about having the right audience. Okay. So, where are we? Okay, so now we'll go to our second example. So here, our auth server is going to be external. We're going to use Google accounts. Our client is going to be an InterSystems IRIS instance and a web application running thereon. Our resource server is going to be Google Photos. We're asking for this scope. Google scopes tend to look like URIs. Ours ends in photos library.read only. The resource owner is me and my Google account. So we are going to, for our resource, we're going to, in our web application client, request some information about all of the photos for this account and then get the actual image for one of the photos. So let's do that. So I'm on my client, and you can see here that I've actually configured multiple server descriptions. I'm pointed to different ones, but one of them is Google. And so we're going to look at Google. So we were able to do discovery just like with the auth server, but we actually can't register dynamically. So first I had to set up all the client information inside Google, and then I had to copy it here. But of course I had to copy this client redirect URL up into Google so it would know, oh, it's okay to send authorization codes back to this address so that the instance can get tokens. So you're going to need that URL, set that up in Google. The client name doesn't matter here because we're not going to register dynamically, so I just picked something. We're a confidential client. We got a client secret from Google. Oh, and like I said, this client redirect URL, very important to have that and to set that up in Google. And skipping front channel logout, still just using authorization code, still using basic auth because we have both a client ID and secret. So, oh, I'm not showing you my client credentials because they're actually real in Google. So here's our client application. The first thing it does is it gets introspection endpoint. This is going to get us the redirect URL to send us to the auth server. So we're going to get that redirect URL. We're going to put that in a link at the bottom that the user can click on, and that'll send them off to the auth server where they'll sign in and grant access. Then once that process is done, we'll come back to this page and we'll check, oh, hey, does this instance have this token for this specific client app that has these specific scopes? And if that passes, cool. We'll also get the contents of that token. And then we'll print out, you are authorized. Then we'll create an HTTP request pointed at Google Photos, use an SSL config, obviously. We're going to add that access token to this HTTP request, and then we're going to access media items. And then we're going to get a response. That response is going to be some JSON that has information about all the photos for that Google account. We're going to take the base URL for one of those items. We're going to write out that base URL. We're going to link to it, and we're going to display the image at that base URL. So let's see what that looks like. Grand. I am logging into my web application to access this page. Please require logins. So here we are. You're not authorized. Click this link to go to the auth server. Hey, it sent me to Google. And we're putting in a lengthy password. Your security engineer reminds you to use a secure password. It's going to warn me, hey, this app isn't verified. I made this app, so I know that that's okay. Continue. It's saying asking for access to view your Google Photos library. I choose continue. And then it's going to send me back to my original page. And look, I am authorized. And look, it's displaying this base URL. And look, it's showing me the Batmobile located at that URL. And I can even click that link to go to that Batmobile directly. Grand. So those are our two scenarios. Cool. So let's switch gears, right? We just, in the two examples we just looked at, a client got an access token from an authorization server to use to gain access to resources from a resource server. A client can also get an ID token to get information about a user and their session, or they can get that same information using OAuth 2 and OpenID and various other ways like the user info endpoint. So the client could take that ID token or that information and use it for SSO, right? We offer a sample OAuth 2Z Authenticate that you can customize, and in there are examples of how to get the username using OpenID or OAuth 2, and then you can specify that in a delegated login for that. You still need to write logic on what IRIS security roles that user's supposed to get, but you can totally get their username and whether their token is still valid using OAuth 2 stuff. We're not going to look at that right now. Instead, I'm going to turn the time over to Pravin, who's going to talk about other practical considerations if you're actually going to be using SSO with IRIS.
All right, hello everybody. My name is Pravin Barton. I'm a developer at the application services team here at InterSystems. I'm in charge of our single sign-on, our InterSystems login. So I want to use that as a case study for using OAuth 2.0 with IRIS in the real world. And this is going to be, as John-Soo Ho mentioned, a very different use case for the same plumbing. So the story with SSO is I have a dozen different applications inside of my organization. Back in the mists of time, each of these had their own authentication mechanism. So all of my users had to remember like a dozen different passwords. They were writing them all down on sticky notes. They were dropping the sticky notes. It was a mess. They hated it. Instead of that, they want to log in to one server, a single sign-on server, and use their session on that server to authenticate them with every other application. This is a very common use case for OAuth 2.0, and we've mentioned there's an extension called OpenID Connect that is practically built for this. So say you're building a single sign-on for your organization, and you decide you want to use InterSystems IRIS. First question is, what is decided for me by the specs, and what is not? So on the left-hand side, is that left? Yeah. We have the hard stuff, pretty much. And that's your authorization flows, your access tokens, ID tokens, the user info endpoint. And that's all specified for you by OAuth 2.0 and OpenID Connect. And there are a bunch of different options. You can choose some. On the right hand, you have stuff you gotta figure out for yourself. And that's basically everything a user sees. So like the user interface and the processes for authentication. I'm gonna give a really quick tour of that using our InterSystems logins as a case study. So first off, we have a login page. You need some way for the user to authenticate yourself. For us, it's just a username and password. That's going to be the most common. If you're, I don't know, a bank, you probably want multi-factor authentication. You want something else in addition to that. But again, this is not specified by OpenID Connect or OAuth. You can use whatever type of authentication you want. You can have them press a thumbprint sensor, use a physical key, something like that. So another big part of OAuth flows is this consent screen. And this particular screen you've seen if you've ever clicked one of those buttons that says, sign in with my GitHub account. This might be a hot take, or maybe it's just common sense. In our SSO use case, you probably don't need the consent screen. And this is assuming that all of your clients are controlled inside of your organization. The user has already granted consent to your organization to their data when they registered. Of course, I'll come back to that assumption about all of your clients being controlled in your org later. Really quickly, what's the onboarding experience for new users? So maybe you have a registration page. For us in InterSystems login, we just have a really simple form where you put in some info and verify your email. What if I've forgotten my password and we're using username password? My best advice for this flow is to look for the OWASP cheat sheet. This is an open source repository of a lot of great security information, and they have some guidance about how to implement that flow securely. And a grab bag of other pieces that you probably want in your identity management system. So maybe you have some communications going out to users, and your users want to customize what they get. Maybe they need to accept some terms and conditions from our legal department. And maybe you want to leverage all this user data by integrating it with your CRM or some other system. All right, now to the good part. How do I practically do all of this with IRIS? The first section is developing that user interface for all of those things. This is a web application, so just use your preferred web dev stack. For our team, a lot of our apps use a JavaScript framework running in the browser, and then some IRIS REST APIs that communicate between the browser and the server. And that's a really great way to make like complex web applications that are maintainable. But this is all really simple. Really all you need is a session management strategy and a couple different web forms. So why not keep it simple with CSP and vanilla JavaScript? That's what we do. And then beside your user interface, you'll need some database of user information. You're running on IRIS, you have that database. So create table your users. All right, the more complicated part of the practical details. How do I integrate this all with IRIS's platform security features? On the client application, this is kind of simple. You're going to want to use delegated authentication. This lets you implement a simple API called the zauthenticate routine to customize how IRIS does authentication. So there's a sample on our GitHub repository in samples.security called OAuth 2.0, and I recommend that as a great starting place. The only thing you need to change there is the logic about access control. So maybe some users, you look them up and you see they're an admin. So you give them special IRIS roles. And other users, you look them up and you see they don't even exist on your system. So you don't give them nothing. The more complicated part, a little bit more complicated, is the authorization server. On the server, you don't need to worry about zauthenticate. Instead, you implement authentication in those custom OAuth 2 classes that you saw before. So the authenticate class is going to show your login page and implement authentication. So for our case with username and password, we just look at the submitted password, we hash it and salt it, compare it against our hash stored in the database. Then our validate class does a database lookup in that database of user data and populates all of your OpenID user data claims with their information. Third thing to worry about is there's a checkbox on the authorization server configuration called enable user sessions. You need to check this, otherwise your users will have to re-authenticate every time they go back to your SSO. And that kind of defeats the purpose, right? And then finally, where do I put everything else in the user interface? So the profile edit, the registration, communication preferences, stuff like that. For that, we have a separate web application on the same IRIS instance as your authorization server. Some of those things are going to require unauthenticated access. Like if you're creating an account, you don't have an account yet, so you can't be authenticated. Other things are going to need to be authenticated. How does that work? This application is just going to be another OAuth 2 client for the authorization server running on the same instance. And you could configure that using the zauthenticate just as before. All right, now on to a couple more advanced topics. First off, which clients can use your identity provider? In theory, you could allow any application out on the internet to use your single sign-on. But I'm not Google, I'm not Microsoft. I don't want to be identity provider to everybody because that's not my job. And if I'm missing a consent screen, as I mentioned before, this could be a security hole because some attacker could register their own client with their dynamic client registration and then redirect a user to that client and use that open redirect back from the login page to steal their logged in user information. So I don't want that. I want to lock down the client registration. The OAuth way to do this is to require a registration access token on the registration request. IRIS doesn't support this yet, but it is on the roadmap, and we can promise it'll be there in a future version. In the meantime, you have a couple options. First, I can use some network rules or some web server configuration to limit access to that registration endpoint. And then second, I'm probably going to want to keep a whitelist manually of client IDs that are allowed to use my server. So here's a really quick, simple code sample. In my authenticate class, when you log in, I check your client ID, and I check it against a list in a global. If you're not on the whitelist, I kick you to the curb, our bouncer kicks you out. In our case, we actually whitelist the redirect URI, and that's a kind of a more maintainable way to do it for us. But either way has the same effect pretty much. Second advanced topic, say I want to add some more flexibility to how my users authenticate with the application. So maybe my users already have an account with Google or GitHub or my organization's Active Directory thing, and they want to bring that identity over to my SSO. So here's one option. Maybe each client has a list of allowed identity providers, and when you go to the client, you have the option to sign in with IRIS, sign in with Active Directory or Google, etc. That's really flexible, but the downside is I now have no central database of identities, and I want to keep track of my people. So here's another option that we went with. chained identity providers. Every one of my clients is going to connect to my one IRIS OAuth server. But that server also allows the user to authenticate with any of these other servers. So notice here that server in the middle is playing multiple roles. It's both the server for the client, but also the client for the other servers. So this provides the flexibility while also giving you a central database of all your users' identities. But the downside is it's a little more complicated to implement. All right, with that, I'll turn it back over to John Suho.
Grand. That's our presentation today. We're going to leave you with some resources. I highly recommend this one at the top, Workshop IRIS OAuth 2 on Open Exchange by Alberto Fuentes. A lot of my demo was starter code from him with some augmentation. Very good if you're just starting out and want to understand how to do all of the OAuth stuff in InterSystems IRIS. There are some articles on the developer community, including this oldie but goodie series of InterSystems IRIS Open Authorization Framework by Daniel Kutak. And now the OAuth 2 InterSystems docs, which now you can understand. Sample security on GitHub, that includes the sample OAuth 2 Z Authenticate. And thank you. The end. So we're over time, but we're happy to take questions.
Hi. Is it possible to do integrations with Microsoft's Hello or Face ID's authentication tools, like the way that you do for other applications?
If you write a Z Authenticate, you can write many, many things, and so I wouldn't be certain. I wouldn't be certain what exactly you could write in there, but if you're using a Z Authenticate, that's your code. You can do whatever you'd like, but.
And multi-factor?
Pardon?
Multi-factor authentication, you can.
We have APIs for at least for verification codes. I'm not sure for what else.
Thank you.